A lot of people are talking about ChatGPT and its capabilities, and it's amazing how good it is with various things, including writing an essay or writing a novel. I remember a few years ago, there were some stories written by AI out there, and they were hilariously incomprehensible, and people were laughing at them. But today it has come quite far. However, that's not the point. I want to test ChatGPT on its ability to do mathematics, in particular university mathematics. Let me just ask it a question. Can you do advanced mathematics? And university mathematics is by no means advanced if you want to use mathematicians as the standards. Anyway, I wanted to ask you about topology and metric spaces. Let's see. Okay, so it tells me what topology is, what metric space is, and doesn't tell me a lot about topology. It doesn't give me a definition of topology. But for metric space, it does give me more formal definition than that for topology. I'll ask it a few questions. What is a metric space? It says what metric space is informally, and then it also gives me the three definitions. Okay, that's interesting. And it also gives me some formulae as well. I don't like the way it's typing the answers out. I'll ask it, can you use LaTeX to rewrite, how do you say, rewrite the previous answer? Let's see if it can use LaTeX. Oh no. It's just giving me dollar symbols. That is not what I meant at all. Anyway, I'll leave it to this. This is quite comprehensible, so I'll leave it to that. Okay, let me ask it some questions. I will say, what is a homeomorphism between two metric spaces? And this is standard bookwork, and I expect it to be able to tell me what it is. So it tells me it's a continuous function that's bijective and whose inverse is also continuous. Does it say inverse is continuous? Metric preservation. Mm, I, hmm. This is a bit too strong. I wanted homeomorphic just in a topological sense. But this also works. Yep. Now this thing, the inverse is also continuous, comes as a consequence because of this metric preservation. And this is not necessary for the definition of homeomorphism, but it's just a matter of taste. I know some people might want to define homeomorphism between metric space as one that preserves the distance as well, which I would call an isometry. But it is fine so far. Let me ask it a more Let me ask it to prove something. Um, is it true that any continuous function from any function from a discrete space to any other space is continuous? Let's see. Okay, it is correct because it doesn't tell me. It tries to invoke topology and then look at the definition of continuity in terms of topology, which is fine, which is absolutely fine because it is a metric space and metric space induces a topology, and you can use the topology to define whether the function is continuous, but it isn't necessary until you introduce topology. But it is totally fine, of course. And it is true, as it says here, the preimage of open set has to be open, and then since in discrete topology every set is open, so preimage of any set will be open, so it's going to be continuous. How about something more technical? Let's just ask, does there exist a continuous function from the reals, say, with standard metric to reals with discrete metric? If you watched my video, you probably know that only continuous functions from R with standard metric to R with discrete metric are constant functions. Okay? Oh, it says there is only one such continuous function, and it is the constant function. That is absolutely true. And this is impressive. I wasn't expecting it to be able to come up with this. Okay, I haven't read the proof in detail, but the fact that it told me it is the only continuous functions are the constant functions is impressive enough for me. Okay, let's see what happens if I ask. In the previous question, I asked it if any function from discrete metric space to any other metric space is continuous. This is true. Now let me ask the same question, but an example of it. So let's just ask, is the identity function from R with discrete metric to R with standard metric continuous? It is not continuous, that's true. And to show that the identity function is not continuous, what does it do? We need to find an open set in R with a standard metric whose preimage under the identity function is not open in R with a discrete metric. No. Wait. It says it's not continuous. The identity function from R with discrete metric to R with standard metric is not continuous. That is false, because any function, it doesn't have to be the identity function, any function from R or any set with discrete metric to any other metric space is continuous. And the reason is simple, because preimage of any function will be an open set. I'm not sure if that's making sense to you. I'm just telling you that the answer it has given is a wrong answer. We've got our first wrong answer here. Let's see what does it say. Okay, to show that the identity function is not continuous, you need to find an open set in R. The standard metric whose preimage under the identity function is not open with the discrete metric. Okay, we consider 0, 1 in R with the standard metric. This is an open set. That's good. The preimage of the identity function is also the same thing. Since the discrete metric on R has the property that every subset is open, the preimage of the identity function is itself, however, 0. No, 0, 1. No, this paragraph is problematic. It says, in the discrete metric space, every subset is open. So therefore, in particular, this subset should be open. However, it says 0, 1 is not an open subset of R with discrete metric. This is wrong. I'll just say, let's see what happens if I just tell it his last answer is wrong and see if it can figure it out. I'll say it's wrong because 1 is open subset of R with discrete metric. Let's see what happens. Okay, therefore identity function from R with discrete metric with standard metric is continuous. Okay. Discrete metric open, that's fine. Revisit the continuity from R discrete to R standard with the identity function. Now we want to show it is continuous. Since every subset of R is open with discrete metric, the preimage will also be open, therefore it is continuous. Incredible. I just told it where it went wrong and can tell me that it went wrong. And this is impressive. Okay. I wonder if I should ask it something more technical. I will say, is it necessary to check that the inverse map is also continuous when checking if a function is a homeomorphism? Let's see. Okay, it is necessary. Okay, bijection inverse is continuous. Okay, let's ask it. Can you give an example where we have a continuous bijection, but it is not a homeomorphism? We know plenty of examples. Let's see if ChatGPT knows. 0, 1 with standard Euclidean topology with a subspace. Now this is not a bijection because sending x to e to the power of 2 pi I times x, and if you plug in x equals 0, you get the 0.1, and if you plug in x equals 1, you also get 1, because e to the power of 2 pi I is equal to 1. So the function, so this example doesn't quite work, and because 0 and 1 are both mapped to the same point, the example you gave is not a bijection. Okay, let's see. A continuous bijection, that's not a homeomorphism. I thought it was going to try to fix this by changing this closed interval to half open interval so that one of the zeros and 1 is included and the other one is not. Then you don't have the problem where 0 and 1, they are both mapped to the same point. But it decides to abandon that thing altogether. Let's see if it comes up with a different solution. Okay, f of x equals 2x is a continuous function from 0, 1 to 0, 2, but it is a homeomorphism. Is it trying to say it's not a homeomorphism? Let's see. Function f is a continuous bijection, as it is a linear scaling. Yes. This function is not a homeomorphism. Oh, it's not a homeomorphism. Why? The inverse is y over 2. That's fine. While the inverse function is also continuous, yes. It is not continuous at the point 2 in y. What do you mean? As you approach 2 from the left, the inverse function maps y over 2 to y over 2, which approaches 1 as y approaches 2. However, when y equals 2, f inverse of 2 equals 1, and there's a jump in the function at that point. And this is total nonsense. This function is continuous at 2 as well. And this is a homeomorphism. And this paragraph does not make sense. Since the inverse of the function is not continuous at y equals 2, the function f is not a homeomorphism despite being a continuous bijection. No, this is definitely wrong. Okay. I guess it demonstrates like how far it has come. I was quite impressed with like it got some of the answers wrong. For example, identity function from R with discrete metric to R with standard metric continuous. It said no. And then I told it why his answer is wrong. And then he went for S and he came up and the AI came up with the proof as to why it is the case. However, even after telling it, no, the question was to, yes, it got the right answer, but then it gave me a wrong example. Because this example is the standard example, but it just needs to include one of the points and exclude another one of the endpoints. And this would be a good example as to something that's a continuous bijection but not a homeomorphism. Then it just went on to just give us a different example that is a homeomorphism, but it is trying to prove it is not a homeomorphism. And of course, when you try to do that, what do? You just scribble down all the nonsense and hope your examiner can't see what you are writing. Unfortunately for this AI, like we can see immediately what it is trying to do, and we are not going to give it credit for trying to sell us wrong answer. Hope you enjoyed this video. If you like this kind of videos, and if you want me to just ask ChatGPT about other branches of mathematics, then do let me know down in the comment section below, and I will ask it some other questions. Bye for now.